PBS streams video, and you can too. Can we all give a warm welcome to Edgar Roman?
Thanks, everyone. So what I did say just a second ago is true. I am going to focus primarily on video streaming and video encoding. We actually use Django in Python and Flask and a lot of different other Python frameworks within PBS. If you're watching video on pbs.org, most likely that video was streamed from a Python app, or at least the video pointers were given to you by the Python app. So what I'm trying to do in this talk is give you, if you've never been exposed to video encoding and video processing and streaming, a little bit of background so that you can start, you know where to start, and then you can plug it into whatever your Python framework of choice is. So that being said, I'm also talking about the state of technology as it is in 2013. In a couple years, things are going to be vastly different, and so what we're talking about now is pretty much, it's going to be good for the current state. And if you're on the internet viewing this in 2018, then just please chuckle humorously to yourself. Jump into your auto-driving car, put on your Google Glass, and watch a hologram. This is probably not going to be relevant to you. And of course, the lawyers make me put that stuff on the bottom. So, all right, so our goal at PBSD was to really make video accessible to as many people as possible. This is a broad swath of people, anywhere from on mobile devices to IE6, on schools who are running, Windows 95, to the guys who are running the latest high-end Retina displays on their MacBooks. So that's our goal. Your goals may be totally different, and so that was going to affect your choices about how you actually encode your videos. But our goals at PBSD is to make this as accessible as possible. So a little bit of history first. I'm not going to spend too much time on this. In 1994, MPEG-2 the specification was finalized, and it really sort of ushered into a modern, the era of modern. There was digital video before this, and there's going to be digital video after it, but that was a big milestone. It is the basis, for the most part, for your broadcast terrestrial video TV stations that you're watching. And if you pop in a DVD, at least not Blu-ray, but some of the older DVDs, that's how you watch, that's the actual encoding that's on the disc. Now, MPEG-2 is great. It's a lossless format. It's easy to encode, easy to decode. Doesn't require a lot of horsepower, but it generates very large files. And that's not too bad if you have a CD or DVD that holds several gigabytes, because you ship them in a little plastic box at Best Buy, and people can pop them into their DVD player and watch them. Not so good on the internet, where you have much more constrained bandwidth constraints. So 2003, MPEG with H.264 the specification was finalized. And that really was a revolution in internet video streaming. So much like MP3 was to WAV, MP4 is like to MPEG-2. The mathematics that they use to create these lossy formats, I don't pretend to understand. They do some serious computation to compress and encode these videos into a much smaller file than you used to have with MPEG-2. However, the downside of that, it's much more complex to decode and to encode. So you have to have a lot more video or CPU horsepower in order to decode or encode MP4. But if that's your constraint, if bandwidth is your constraint and CPU isn't, MP4 is a great format for you. Now there's a lot of other formats out there, OGG Vorbis, WebM, and VP8, and these are up-and-coming formats, and we'll see a lot more of them in the future. In fact, if I were a betting man, and I am, I'd actually bet on VP8, VP9 in 5 years. But currently, the state of the art is H.264. A little more about MPEG-4 with H.264. The success of this is really driven by a couple factors. One is, it is playable almost everywhere. A huge number of platforms actually stream and play MP4 video, And so it's a really good choice for you if you want a wide penetration into the video market here. It has excellent compression, so a lot of the lower bandwidth streams like mobile and some of these other smaller devices can actually stream this pretty regularly and pretty easily. The downside is it's incredibly flexible. And with that flexibility comes options. And you can pick all kinds of different encoding options for MP4. Now, for people like me, who can hardly pick out ice cream toppings, what they did was they added a couple of standard profiles, baseline, main, and high, which standardize a bunch of these options. Now, it doesn't mean you have to do these profiles. You can encode your MP4 however you'd like. But if you stick to one of these baseline, main, high, you have a much better chance of arbitrary video players being able to stream your MP4. And finally, there's a shadow over H.264. It's not a panacea. There's an organization called MPEG-LA that holds patent licensing agreements on top of the encodings that are used in H.264. Now, anyone who actually builds a product, like a video player or an encoder or decoder, is going to have to pay royalties to MPEG-LA to be able to license their patents. However, in August 2010, MPEG-LA announced a statement that if the video is free to users on the internet, then the end users, which means you guys, will never be charged royalties. I'm not a lawyer. I don't know much about how binding that is, but it's something to think about when you're talking about streaming video. So it's important to mention this. Assuming you have picked whatever video encoding you'd like to use, the next step is to actually stream it, actually get it from your server to the end device, and to have them play it. And there's a couple general options for this. There's actually a lot of options, but 3 primary ones I want to talk about. The first is good old HTTP. Just download this file, drop it down on your disk, or drop it down on your device, and start streaming the video. This works really well. A lot of devices support it. However, it's incredibly wasteful in bandwidth, especially for PBS, where we have 1 and 2 hour shows that we put online. If a user starts streaming the video and they have a good BIOS connection and download a significant chunk of a 2 GB file, and after about 10 minutes they decide they don't want to watch this thing anymore because it's too boring or it's too something else, they will turn off, they will just close their browser window, browse away, and we've taken the hit of the download off of our CDN. So for PBS, HTTP download is not the best choice that we use. RTMP is a good choice as well. It actually is very bandwidth conservative. It only streams what you need to stream. But the downside, of course, is that you need commercial software to be able to stream this. You need a flash media server to serve it, and you need a licensed player to play it as well. Finally, there's a new format that's been recently up and coming. It's endorsed by Apple, and that's probably one of the reasons it's gaining traction. It's called HTTP live streaming. It's pretty much just like HTTP, but instead of having one giant 2 GB file, you break it up into 3 to 10 second chunks. So the player can download 3 seconds or 10 seconds at a time, and it only buffers a minute or 2 in the future. So in that case, if you have a good, smart player, it will conserve your bandwidth. At the same time, it will allow the users to just use straight HTTP, which has a lot of advantages, including CDN and firewall implications. There are a heck of a lot of others. I'm not going to talk about them now, but you can research them around. This is only a fraction of what we have out there. And finally, you want to be able to play back the video. And this is usually either software or some sort of browser software codec on the end device, whether it's a browser or a mobile device. Now, PBS has certain requirements. You may have different requirements. In some cases, we do need to serve ads. We are big fans of having closed caption support for the deaf of hard of hearing. And we need it to be customizable. We like to change our social media network links. We like to link back to our shop site. So in terms of what we needed a very rich flexible environment, which means that we naturally tend toward Flash. And right now, we're using the open source media framework, which is a great framework. It does everything we need, but it's definitely roll your own. Go get a Flash developer and invest in their technology career path, because they'll be doing a lot of Flash here. We also use some HTML frameworks. I'll get to that in a little bit. And we leverage whatever native device players we can, if possible. So how do we get started with just streaming video? If your first target, like ours was at PBS, we wanted to target desktop browsers. So we picked MPEG-4, H.264, to lower the file size. We picked the MP4 main profile, which is a very good happy medium between high and baseline bandwidth. It has a moderate amount of software decoding or hardware decoding, but it also has very good compression. We deliver it via RTMP, mostly for the bandwidth conservation, because we stream millions of hours. And there's broad support in the Flash players. Our OSMF player is customizable as we see fit, and we can tweak it and move it around, move buttons around as we want to. Now, something to note, when we started streaming in 2009, we started at 400 kilobits per second, which was pretty good back then. It has now gone in four short years to already being double or even triple what that is. And so users with large screens, especially if they have set-top boxes like Roku and these other video players set to this giant 74-inch screen in their living room, sometimes even 1.2 megabits not going to look real great on these giant screens. So this is always pushing the boundaries. As I said before, this stuff will change over time, and numbers will get higher, and encodings will change. So a quick diagram. I mean, this is literally what we do, and it's not real hard. We put our MP4 files on S3. We put a CDN in front of it. Now, we happen to use CloudFront because it has RTMP built in as a service, but many other CDNs do that as well. Limelight, Akamai, those, so on and so forth. And we stream this using our player down. Our Django app essentially just renders the player down, and we stream right from the CDN. So your video streaming setup could be pretty much like this. In fact, if you even want to go one step easier, I would pick MP4 main profile. You can use progressive download if that doesn't bother you and you have a constrained set of audience users. And maybe even use the HTML5 video tag to stream this stuff. So in the end, the technology is there, the base technology is there to make it incredibly easy, assuming you go into this with eyes wide open. Mobile devices. So increasingly, mobile devices are a bigger part of our video consumption, whether they be iPad, iPhone, Android, so on and so forth. We target the two biggest chunks, iOS and Android, which means, sorry Windows guys, if it works, great. If not, sorry. So iOS doesn't support Flash, but they do support and embrace the HLS, which is great because HLS is a nice format. It has auto bitrate built into it and built in the protocol. I can use any HTTP CDN. I don't have to use an expensive commercial software server. And the iOS device has built-in player. In addition, I know the capabilities of most iOS devices. They have a very standardized set of hardware and horsepower, so I can tweak my video settings to make sure they work on pretty much all modern iOS devices. Android, on the other hand, supports Flash poorly, supports HLS poorly, and it supports MP4 playback poorly. And that's because the varying hardware that runs Android software is so great that it's very difficult to actually determine one single setting that will work on all Android hardware. And so, unfortunately for our Android streaming audience, we actually fall back to MP4 baseline, which is the biggest file size in terms of encoding and compression, but still is an adequate video rate. As time goes on, I suspect we'll be able to migrate to either HLS or some other profile for MP4 and make the Android experience better. Finally, one more thing. The capability detection on these mobile devices. They have Wurfel and Device Atlas, and those are great for determining media capabilities and so on and so forth. But for video playback, support is actually very poor. A lot of these services essentially indicate a Boolean value saying, yes, this supports video, or no, it doesn't support video, and it doesn't give us a whole lot of insight. So we punt for the most part, and we give them the baseline video. So a quick diagram. You have your HLS, which actually generates thousands of files, thousands of tiny little 10-second chunks, and you just serve them up to the iOS. There is one file, it's called the manifest file, that overlays and tracks every single video file that's out there for a particular stream, and that's passed to the device, and the device actually does the logic of which chunks to get. And then for Android, we just simply put up an MP4 baseline and say, here's what you got, Android users, and good luck with that. A little bit about HTML5, the video tag. It's great. I think we're definitely moving in the right direction. It lets most users who actually want to serve video have video on their site very, very easily. However, if you want a rich environment that we need, for example, for streaming PBS, it's not there yet for us. It may work for your needs, but for us, it's pretty basic. We don't have advertising, there's no captioning, or there's captioning is very spotty, and the video codec support is based on whatever each browser is actually rendering this, which varies widely. However, there's some really good HTML5 frameworks up and coming. So Video.js, Media Element, and JW Player all have really good full-featured HTML5 frameworks that I think in a few years are going to be much better and may actually replace Flash for most of our full-featured video, but not yet. And then transcoding. So you may not think about this as a need, but you really do need to get some sort of transcoding to get your video from whatever source you get it from into a streamable online source. So a lot of really good tools locally, Handbrake, FFmpeg, and X264 are great if you're just doing onesie-twosies. If you have a large set of videos that continually come through, like we do at PBS, then you actually have to use either an online service or build your own online service using these tools. And so Zencoder and encoding.com both have pretty good online services that you can stuff in all kinds of different formats, and they will return to you whatever you specified in terms of the output format, and they're pretty good. So at PBS, what we do is we start with a 5 megabit MP4 file, and from this we create about 16 streams. And if you want to look at what streams and encodings and values we have, I've posted them here. You can look that up later. But we try to sort of future-proof ourselves with the 5 megabit because we know that over time, the guy who filmed a show is going to be gone in 5 years, and I'm going to have to retranscode his video into something, some new format that I haven't thought about that now. So keeping an archive of these mezzanine videos is really a pretty good idea for us going forward. So a quick overview of the PBS video flow. An editor who is responsible for the video uploads it to our CMS, which is written in Django. We store the original file in an archive, and we send it to our transcoding service using our 16 predefined video streams. Transcoding service finishes those up, stores them back into our servers. We save those links, and then when a browser or a viewer hits our website, we try to determine as much as we possibly can about their video playback capabilities, and we render either a Flash player with HTML5 fallback or native iOS or Android video tags to get them playing on the browsers. And that's pretty much it in a nutshell. One more thing, if you're concerned about people stealing your videos. And maybe you should be. Maybe your videos have proprietary information or other information you don't want getting out. It's a tough challenge. And really, at the end of the day, it's how can I make it harder for them to steal it than to get it via approved channels? Because if you let people get it through approved channels as an easy path or an easy way, they are not very motivated to go through great lengths to get this to steal your videos. And so for PBS, we're actually in a pretty good situation. Most of our videos are actually streamed for free online, and so we have we can get away with minimal protection of our high resolution videos. So if you choose to go down the route of a DRM strategy, just check out this link, the DRM Graveyard. It's possible you won't be able to play your own video in 5 years. And that's all I had, so I guess I want to take some questions now.
Hi, I would like to know how long did it take for you to actually develop these video digital media specs, and like how do you future-proof yourself given that formats are going to keep on changing, resolutions are going to keep on changing?
Oh, great. So the question was, how long did it take us to get to these video specs, and how do we future-proof us going forward? Well, we're still working on it. Honestly, the things evolve so fast. New versions of iPhone Retina displays show up, so we have to constantly add new bit rates and tweak our bit rates on a continuing basis. It was painful in the beginning because there was a lack of information, and so one of the things we want to post is to say, hey, here's our streams, leverage what we're doing already, and you can build off from there.
So my question is, how do you test the end user experience with all the targeted devices you have and all the different potential environments? Do you have a testing team, or do you rely on like surveys from users, or could you elaborate on that process a little bit?
Right. So the question was, how do I test the video on the endpoint? And for the most part, we have a QA team, and they do have as many devices as we can afford, which is not a whole lot, but we try to get some. There are services out there, online services, that let you have a virtual machine in a lot of these iOS devices and even browser devices, so we don't have to have a massive test lab, but we do actually have to test them on a lot of different services. So we generally rely on external services for the total breadth, but we try to have a core set of, we support these 100%, so we actually have these physical devices in-house.
You didn't mention any sort of live broadcasting. Do you do any live broadcasting with PBS?
So the question was, what about live broadcasting? Live broadcasting fundamentally uses many of the same technologies we use here, and actually many of the same encodings that we use here. It's sort of a talk unto itself because there are some tweakings that you have to do depending on if you're using HLS or MP4 or RTMP for the streams. But we do some live broadcasting, but it's generally a different infrastructure.
Yeah. Do you have problems scaling with that on live broadcasts?
We generally don't. The question is, do we have problems scaling live broadcasts? And if you use a CDN that's worth its salt, then you generally don't have a problem with this at all, especially for live streaming.
Okay.
Mm-hmm.
My question is primarily mobile, with with the ability of downloading for later viewing. Are the limiting factors on that purely legal or technical, where you know, for offline viewing later?
Right. So the question was mobile viewing for offline, and the primary hurdle for us is legal. Our licensing agreements don't allow offline viewing, only online streaming. And we also have a shop program in iTunes that also fills that niche, so it's a business issue for us. But in terms of implementing and rolling your own, it shouldn't be that difficult, especially if you're supporting HTTP progressive download. You may have to do some client-side storage and rendering, but you may run into problems with just local storage on the device. Okay, we got about 3 minutes left, so we'll probably do a couple more questions.
With regards to video that you might do internally for PBS, maybe the editorial group that produces a lot of these. Is there any requirements for frame-accurate playback on the web? And frame-accurate playback using one of these, via a browser? I know the BBC has done a little bit of work in that regard. I was wondering if you guys might have dabbled at all.
Right. So the question was, do we have any requirements for frame-accurate playback? This is in the weird world of TV broadcasting now. We actually, the agreements that these guys sign are incredibly complicated, and they may license music for the TV broadcast. So we actually have a media operations center that cuts a special version for the online streaming with all of the music removed or added or whatever we can do. So we actually get special cuts at PBS because we have the resources to do a media operations center.
So this is a Android-specific question. It struck a chord when you said that there is no really easy way to figure out what the capabilities of the device are in terms of video playback. You said that you have a lab, and you also said that the later versions of Android support HLS. So, and it seemed to me from your talk that you use baseline MP4 for all Android. Have you sort of, are you thinking of being a little more granular about it? Have you experimented with, yeah.
Right, so the question is, when are we going to get our Android streaming correct, right, or better? And we do want to do that. It's actually, we're thinking about building up some sort of device index based on user agent and a number of other capabilities. We don't have it to the state where it's even reasonable or useful for someone else to open source it, but we're thinking about that in the future in terms of what do we learn, and maybe we can share that as well, or even contribute it back to Workforce and these other device capability systems. So.
Okay.
Okay.
Unfortunately, we're going to have to cut that short. Thank you very much, Edgar, for a great talk.
I'll be outside if you guys want to ask some questions.
Yeah.